Welcome to week 5, GSS 1 Mathematics first term. Let's consider equivalent fraction. Your week 5 is still on fraction. That's the general topic. But now we need to consider what we mean by equivalent fraction. This is something that you hear, and in fact, you've been doing it from primary school. Now, what do you mean by equivalent fractions? This is not talking about one fraction, many fractions. Now, fractions that represent the same value. They represent the same value. They actually mean the same thing. They are called equivalent fractions. So let's say equivalent fractions are fractions that represent the same value of a whole number. So the same value that represent the same value of a whole number. In short, fractions that have the same value. So you can start with a fraction as small as 2/3. So we can generate many fractions which are equivalent to this. So although they may not have the same numerator and the same denominator, but the numerator and the denominator will be the multiple of the next one. They will be the multiple of each other. So how do we generate fractions which are also equivalent to this? It's just simply by multiplying the top and the bottom by the same number. So that means in general, let me first go for general. So if you have A over B, to generate another equivalent fraction to this, it's just by multiplying by the same number. If I multiply the top by n, I have to multiply the bottom by n as well. So that means, that means A over B is still equal to A times n all over B times n. Just make sure you multiply by the same number. Now, apart from multiplying, we can also get equivalent fraction by dividing by the same number. Or if we have A over B, another fraction that is equivalent to A over B is to say A divided by n over B divided by n. So we can use division also to achieve equivalent fractions. So that means for any fraction, we can generate as many equivalent fractions as possible. So for example, if I start with 2/3, so another fraction that will be equivalent to 2/3 by multiplying. If I multiply by both the top and the bottom by 2, for example, that means I will have 2 times 2 all over 3 times 2. 2 times 2 will give me 4. 3 times 2 will give me 6. So that simply means that 2/3 is also equivalent to 4/6. Now I can generate another one. If I start with 2/3, that means I can multiply the top and the bottom by 3. So I will have 2 times 3 over 3 times 3. So this will give me what? 6/9. 6/9 is also equivalent to 2/3 that I started with. So if I can still try to do more. If I have 2/3 initially, I can still generate more, maybe by multiplying the top and bottom by 4. That means I will have 2 times 4 over 3 times 4. 2 times 4 will give me 8. 3 times 4 will give me 12. Meaning that 8/12 is also another equivalent fraction. So that means if I can compile all my results, so they will still give me the same fraction. So I started with 2/3. Then if I multiply both top and bottom, I will have by 2, I will have 4/6. If I multiply by 3, I will have 6/9. If I multiply by 4, I'm going to have 8/12. If I multiply by 5, I will have 10/5. 15. If I multiply by 6, I will have what? 12 over by 6, 12 over 18. In fact, I can multiply by a bigger number. Even if I multiply by 100, I will have 200 over 300. And it can continue like that. So all of these fractions are equivalent to each other. So it is not only by multiplying, it can be by division as well. It can be by division as well. So let's see how we can use division to generate equivalent fraction. So if I start with 30 over 80, for example, so I can decide to divide both the top and the bottom by 2. So if I divide both the top and bottom by 2, okay, we started with 30 over 80. That means 30 divided by 2 over 80 divided by 2. This will give me what? 15 over 40. So that means 15 over 40 is also equivalent to 30 over 80. They are equivalent fraction. So I can still decide to go more, probably by dividing the top and bottom by 5. So this is 15 divided by 5, that will give me 3. 40 divided by 5, that will give me 8. So that means 3 over 8 is also equivalent to what I started with. 30 over 80 is the same as 15 over 40, and it is the same as 3 over 8. Can you see what equivalent fraction can do? Now, the curriculum also say that we should learn the application of equivalent fraction. We should learn the application. Let me clean the board. The application. So let's see a real life application of equivalent fraction. Follow me. A real life application of equivalent fraction is that, for example, now, if you have a pizza, so you have a pizza. So, you know, the UK people, they will say pizza. So, but in Nigeria, we call it pizza because this is spelling pizza. So, the only Igbo people that even have the English, they call it pizza. Okay, so pizza. Now, if you have a pizza and you divide, you know, pizza is always having different sector. They always divide it into different sector. Sometimes they will divide it into 4. Sometimes they will divide it into 6. It depends on the division. So sometimes they just divide it into 2. So let's say you have a pizza that is divided into 2, like this. So if you eat 1 out of these 2, that means you have eaten 1 over 2, which is half of the pizza. So half of the pizza. Now, for somebody that did not divide his own into 2, probably divided it into 4. Let's say another person divided his own into 4. So, and probably this person ate 2 out of 4. Let me shade the part that is eaten by the other guy. So this person has eaten 2 out of 4. So you ate 1 out of 2. So you ate 1 over 2. And this guy ate 2 out of 4. Both of you, numerically, you have eaten the same thing. Because when you watch here now, this man has eaten half of the pizza, and this second man too has eaten half of the pizza. So it means both of you have eaten the same amount. So you can see that 1 over 2, which is half, is also the same as 2 over 4, which is also half. Because at the end of the day, when you simplify 2 over 4, it will give you 1 over 2. Or 1 over 2 is simply a multiple. The 2 over 4 is simply a multiple of this. Just by multiplying 1 by 2 and 2 by 2. 1 times 2 will give you 2. 2 times 2 will give you 4. So this is the application of equivalent fraction. So that means if somebody tells you that he has eaten half of his food, and another person said he has eaten 2 over 4 or 2/4 of his food, that means both of you have eaten the same thing. Even if you still divide the pizza into 6 and you add 3 out of the 6 equal parts, then you are still talking about the same thing. The person that ate 3 out of 6 is still talking about the same thing. Even if you divide it into 8 and you add 4 out of the 8. So 4 over 8 is still equivalent to this. You can see what equivalent can lead to. So this is a real life application of equivalent fraction. Now, let's see how we can apply equivalent fraction, what we can use it to solve in mathematics. So equivalent fraction can be used to find missing number in a particular arithmetic equation. So missing number, application of equivalent fraction. So number one, we can use equivalent of fraction to find missing number. Finding missing numbers. We can also use equivalent fraction to reduce fraction. Reducing fractions to their simplest form. We call it simplest or lowest form. And then we can use the concept of equivalent fraction under ordering of fraction. Ordering of fractions. So under ordering of fraction, like arranging fractions from the highest to the lowest. Now, in this particular video, I am going to do this and this alone. This and this. So then, probably in the next video, I will talk about ordering of fractions. So because this is also part of your curriculum. So now, this is even in week 6. So I will deal with this in week 6. But I will deal with this right now in this video. So let's start with finding missing number. Finding missing number. Very, very interesting. Very, very good. Now, the concept of equivalent fractions, let me quickly get some examples. So the concept of equivalent fraction can be used to find missing number. You will see, you find it very interesting. So for example, you can, let's see the first one, finding missing numbers. Question can give you 2, let me start with 5 over 7, and the question give you box here. Give box, this is primary school work. Now write box over 42. Box over 42. And you are asked to fill in the box with the appropriate number, with the right answer, the right number. So all you just need to do is to check where you have complete number. You can see there is denominator here, and we also have denominator here. You can use this to generate this. So what have they done on 7 to generate 42? So that means they have multiplied 7 by 6 as 7 times 6. You see, 7 times 6 gives me 42. Definitely, I will use this same 6. This 6 is known as the scale factor. The scale factor. So I will use this scale factor to multiply the 5. So this is multiplied by 6 also. 5 times 6 will give me 30. That means the answer has to be 30. This is one way of doing it. So sometimes you can use the cross multiplication method. Method 2. So if you have 5 over 7 equal to box over 42, you can cross multiply. So and have 7 times box. This is 7 times box equal to 5 times 42. Now, to get the box, I will just divide both sides by 7. Divide both sides by 7. 7 here, 7 here. 7 will cancel 7. So box will now be equal to, now we need to simplify this or reduce this. 7 here, 1. 7 in 42, that will give me 6. So I can now say 5 times 6, that will give me 30. So that means the box equal to 30. Very, very easy. So sometimes it may not be box that they will put. They can put letter here. Probably there's a 5 over 7 equal to x over 42. We are still talking about the same thing. Now, you can have another question that comes from reduction. So still on finding missing number. You will observe that the new fraction is kind of smaller than the original fraction. For example, if you have 48 over 50 equal to 48 over 90 equal to, so we now have the missing number at the bottom. Then at the top we now have we have 8 at the top. So now, how do we know what will go in the box? Very, very interesting. So clearly, you look at what they gave you to know what you are going to do to the missing one. So now 48 reduced to 8. How does this happen? It's simply by dividing 48 by 6. They have divided 48 by 6. So this is the scale factor. So 6 is the scale factor. So 48 divided by 6 is going to give me 8. Then that means I must divide 90 also by 6. So I will have 90 divided by 6. That will surely give me 15. 15. So therefore, so the answer will be 8 over 15. You can use the other method too, method of multiplication. Now, what will now happen if you have many of these? So sometimes you will not just have two, you not just have left and right only. You have many of them like that. For example, this question, look at this very simple question. You have 4 over 7 equal to 12 over box equal to box over 35 equal to box over 49 equal to 44 over box. Interesting. So now this is where you have to be very careful. So you will always, please, this first fraction is what you should always use to generate other ones. So once you use this one to generate this, go back to this again to generate this. Go back, come back to this again to generate this. Come back to this again to generate this. Don't say because you have generated this, you now want to use this to generate this. It may not work sometimes. It may confuse you. So use this to generate every other one. Always start, always go back to the start. Excuse me. Always go back to the start. Now, 4 over 7 equal to 12 over box. 4 times what will give me 12? So that must be 4 times 3. 4 times 3. Then I must do 7 times 3 to get what is here. 7 times 3 is 21. That means this is 21. So the scale factor to generate this is 3 times 3. Now, what happened between this and this? Aha. So let me clean this away because it must be something different. 7 times what will give me 35? 7 times what? So that's 7 times 5. Give me 35. Then I must multiply this by 5 also. 4 times 5, that will give me 20. So that means this will be 20 over 35. So I still have to clean this again because they will never be the same thing. Box over 49. So they gave me 49. 7 times what will give 49? That's 7 times 7. Then this has to be 4 times 7 also. 4 times 7 is 28. So you can see how it goes. It's very simple. Clean this again. Clean this again. So this is something you can do in your mind. You don't have to be counseling in your book. You can do it in your mind. But, you know, it's easy for me to clean it with my duster or my hand on the board. Now, this is 4 times what will give me 44. That is 4 times 11. 4 times 11 equal to 44. Then this will be 7 times 11. 7 times 11 will give me 77. You can see that with equivalent fraction approach, we are able to generate all the missing number. So this is the highest level of finding missing number that it can give you. All right, good. Now let's see the second application of equivalent fraction. The second application is reducing fractions to their lowest term. Reducing fractions, or you call it simplifying fraction. Simplifying fractions. Now, under this, you will hear language like simplify the following fraction, or they say reduce the following fraction to their simplest form, or they say reduce the following fraction to their lowest term. Now, we can have some questions on that. Let's quickly look at some easy peasy questions on that. So, for example, if I have this, let's see this simple question. Let's say I have 1 over 108 divided by 108 over 162. So interesting. Now, as a kid, as a young boy that wants to do this, you don't have to choose one big number at first. You can always start small. That is life. Start small and start growing a little bit. So it is clear that many numbers can divide both of them. You choose the same number that will divide this, that same number must divide this. So, but there are so many numbers that can work, but you don't have time to be thinking about that. Just start small. Of course, it's clear that 2 can divide both of them because the last digit here is even and the last digit is even. Then 2 will work. So start with that 2. So divide this by 2. Divide this by 2. 108 divided by 2, that will give me, you can do 108 in 2 in 10, that will give me 5. 2 in 4, 2 in 8, that will give me 4 over 2 in 16, that will give me 8, and 2 in 2, that will give me 1. Now, you can see that this has reduced better than what we had initially. Now, we have 54 over 81. What we have here can still be reduced further. You don't give up yet. You reduce till you can no longer reduce. So 54 over 81, we can still use 3 to divide both. 3 can work here and 3 can work here. So 54 divided by 3, that will give me, is that not 18? That will give me 18 over 81 divided by 3, that will give me 27. Yeah, you still don't have to give up yet. If 2 can still work, you try 2, but 2 cannot work anymore. If 3 can work, you still try 3 again. You don't say, I have used 3 once and I'm no longer using it. No, you can use it multiple times. So, I can use 3 now, again. 3 is 16, 3 is 18, that will give me 6. And 3 is 21, that will give me 9. Now, at this junction, we have 6 over 9, which can still be reduced again. We can still use 3 again. So let's use 3 divided by 3 divided by 3. So 6 divided by 3 will give me 2. And then 9 divided by 3 will give me 3. So what we have here is 2 over 3. 2 over 3, check it. There is no other way we can reduce this. So it's only 1 that we can use. Once you get to that point where it is only 1 that will work, stop. That's the final step. That's the last stage that you can reach. All right. So that is how we can use the concept of equivalent fraction to learn about reducing fractions to their lowest step. Please, if you have not subscribed to this channel, kindly click the subscribe button. Subscription is free, F-R-E-E. There is no payment, unlike the way you subscribe to GoTV and buying data. It's not like that. Just click subscribe. It will notify you when we drop more video. My name is Sheikh Ridwanullah Abu Bakr. I am a maths tutor. Thank you.